Greetings pre-calc students, this is your teacher Mrs. D, and in this podcast we are going to look at a few problems you might be struggling with or taking some extra time to think about from your study guide. The first one here is the fifth root of 32 over 81. So we'll start there, and remember you need to simplify because there's a radical in the denominator. Maybe you just start by breaking it down, the fifth root of 32, fifth root of 81. Now 81 isn't a perfect fifth, but I know 9 goes into 81, 3 goes into 81. There's lots of 3's there. 3 times 3 times 3 times 3. Almost a fifth. Well anyways, 32 is a perfect fifth, so that's nice. You got a whole number of 2 there. And then instead of fifth root of 81, I'm going to write 3 to the fourth. Now remember you're trying to make that a whole number on the bottom, a rational number. This is called rationalizing the denominator. I have essentially 3 to the 4/5 power, and I need to make that a whole number exponent. So I'm going to multiply by 3 to some power. Usually it's the same exact power, and that's what we're used to with square roots, because then you have half powers, and 2 halves make a whole. But in this case, you got to think a little deeper and use a power that's going to add to the exponent you already have. So I'm going to use 3 to the 1/5 power, which will give me 3 to the 1, or 5/5. And then the numerator is just going to be written this way. Could you write it with a radical? Sure. Since we're in the chapter on exponents and logarithms, I'm going to leave it with that exponent. Speaking of logarithms, this next problem is asking us to expand or condense. So I guess I'm going to expand this. And it seems as though there's no property that expands a difference. But if you think about this logarithm, that thing inside there is actually a product of two things. That's a difference of squares if you factor it. And so now this is a product, so I'm going to use that product rule that says I can expand this into the sum of two logs, the sum of the first part of the product and the second part of the product, those two logarithms. There you've expanded it. Now you can't expand any farther because you have a difference and you have a sum. You can only expand for products, quotients, and powers. Those are your rules for expansion. Or condensing, I guess. The last problem here kind of piqued my interest. This is a fun one. Was this solve here in number 19? If you start by dividing by 10, you're going to end up with 4 to some power equals 0. And you might think initially that that's going to be 0, but you know that 4 to the 0 is 1. Not true. How about if you took 4 to a negative power, like 3? Well, you'd have a fraction. It's not going to be 0, but it's going to get closer to 0. For this problem, it might help you to think about that exponential graph. 4 to the x has an initial value of 0, 1, then it goes up here to 1, 4. Notice that this never really reaches 0 because of the horizontal asymptote at 0. So, will the y value ever equal 0, or will this output ever equal 0? No, never. No solution. 0 is not in the range of this function. And so there's no solution, no power that you can take a positive base to that will give you 0. You can get fractions, smaller and smaller numbers, positive numbers, but you will not get 0.